Alright, here we go. This is Math 2, but we're talking about a Math 3 concept. We're doing systems of equations. This is 1.2 out of your green book on page 6. If you're following along, we already introduced it. Now we're going to do a few examples. The first example is y. Y equals negative 3x plus 5, and y equals positive 2x minus 5. First thing you notice right off the bat is that it's y equals. It's a lot easier to graph if we're solving these by graphing if they're already set equal to y equals, right? We automatically can see the slope and we know the y-intercept. We see the slope and we know the y-intercept. We know that it's not no solution because the slopes are different. Okay, so we know the lines aren't parallel. First step, we're going to go ahead and graph the first one. 1, 2, 3, 4, 5. We put a dot at 5 because b, remember this is in the form, y equals mx plus b. The y-intercept is 5, so we put a dot there. The slope is negative 3. What does that tell us to do?
Down 3.
Down 3. Don't say over. I don't like over because over is not a direction. Say right or left.
Right.
Down 3 and then what?
Right.
Right how much? 1. Because this is understood to be negative 3 over 1. So I come down 1, 2, 3 and I go to the right 1. If I were to go in the other direction, what would I do?
Up 3, left 3.
Up 3 and left 1. Okay, so there's the other point. I draw the straightest line that I can on my paper, right, trying to go through those 3 points. If it's a little crooked, it's okay, right? You can use graph paper and a ruler to be more exact, but you get the idea. There's the first line graph. Now what? Now we graph this one. Where's the y-intercept? At negative 5. So we go down 1, 2, 3, 4, 5, and we put a dot. Now what?
Up 2, right 2.
We go up 2, and then what?
Right 1.
And right 1. Right? It has a positive slope. I go up 2 and right 1. Up 2 and right 1. Or I could go down 2 and left 1. Now I did an additional dot in this direction for a reason. Why do you think I did an additional dot in that direction? Right, to show where I think they might intersect. Right, and if I use the big dot theorem, right, then it becomes a little more obvious that what point, where do the two lines intersect? Where do I think that they intersect?
2, negative 1.
At 2 and negative 1. I can guess that, but what must I do to make sure that 2, negative 1 is my answer? I've got to check it. I've got to take the 2 and put it right there. What is negative 3 times 2? Negative 6 plus 5 is negative 1. So the first one checks. How about 2 right there? What's 2 times 2? 4 minus 5 is negative 1. So this one checks. So you can guess where you think that point is, which we thought it was at 2, negative 1, right? That's where the two lines intercept. But you must check it. You must check it. Okay? Questions on the graphing, questions on where you think that they intercept. Do you have to write out one solution? No, you don't. The answer, guys, is the point. That's what I told John just a minute ago. The answer is the x and y. If they intercept in two places, I'm sorry, in one place, and you got the 2 points, that's your answer. Okay, questions on this first example? All right, let's do another. All right, let's look at 10x minus y. Sorry, minus 2y. 10x minus 2y equals 14. And 5x minus y equals 7. 5x minus y is equal to 7. Alright, so we graph the first one. What is different about this problem?
It's not in the way.
It's not.
Say it again.
Not equal.
It's not y equals. Now you could take the time to subtract this over and divide by negative 2, but that's pretty hard. I would rather you just use intercepts, right? What is the x-intercept on this one? 14 over 10. Now, that's a fraction, right? But it's not that bad. 15 over 10 would be exactly 1.5. So 14 and over 10 is a little bit less than 1.5. I can graph that. There's 1, there's 2. There's a little bit less than 1.5. That's not so bad, right? 14 over 10, you can do it on your calculator to get the decimal equivalent, but that's what it would be. How about the y-intercept? It's a little easier. What's the y-intercept? Negative 7. 14 over negative 2, right? To find the y-intercept, I cover up the x. It would be 14 over negative 2, which is negative 7. 1, 2, 3, 4, 5, 6, 7. So it crosses here, and it crosses here. I'm going to go ahead and put my line best I can. There we go. Not too crooked. Alright, so now what? Now what do we have to do? We have to graph the bottom. Okay, so we go to graph the x-intercept. We cover up y. What's the x-intercept? 7 over 5. Well, that looks familiar, right? We do it on our calculator, and what do we get? We get this point right here. I'm going to do it with an x. Right? We get the exact same point. Then we do the y-intercept. What's the y-intercept? Negative 7. So I do it with an x. So one line is exactly the same as the other line. Austin saw that right off the bat. How did you see it, Austin?
10x minus 2y equals 14. Half of that's 5x minus y.
If I take 2 and multiply it here, do I get this?
Yes.
If I take 2 and multiply here, do I get this? If I take 2 and multiply it by here, do I get this? They're basically the same line. They're just written differently. One is a multiple of the other, and our answer is infinitely many solutions. Write it down. This is an example of infinitely many solutions. When one line is exactly a multiple of the other line, then that's the case. Okay, we graphed it out. You may have to show the graph. Okay, you may not just be able to see it like Austin did and say infinitely many solutions. You may have to actually graph. Any questions on how I graphed it? On finding the x and y intercepts? Is everybody a little rusty on that, but it's coming back slowly? All right, let's do one more example. Any questions here before I erase? All right, so which is easier? Which is easier to graph? When it's y equals or when it's in standard form? Y equals. Which method do you think they're going to give you more?
The other one.
The other one. No, just because it requires a little bit more thought. 3x plus 2y is equal to 4. All right, let's do the first one. What's the x-intercept?
2 over 3.
2 over 3, which is 0.6, right? So if here's my graph, here's 1. 0.6 is about right there. The x-intercept on the first one is 0.6. Okay? What is the y-intercept?
1.
Positive 1. So there's my y-intercept, there's my first line, just like that. Any questions? See how easy intercepts are? I don't have to solve for y, move over and divide by positive 2 and all of that. Boom, boom. I got my 2 intercepts, I got my line. All right, how about the bottom? What's the x-intercept on the bottom?
4 over 3.
4 over 3. What is that almost?
1
1 1/4, right? It's in between 1 and 2. It's about right there. What is the y-intercept on this one? Positive 2. Right here, and so there's my point, and there's my line. Now, on my hand graph, it kind of looks like maybe they would intercept somewhere up here. It kind of looks like they're not parallel. How could we double check that yes, they are in fact parallel?
Look at the slope.
We can look at the slope. Do you remember the trick when they're in this form to look at the slope? Isn't it always, is that opposite that number divided by that number?
Yes.
It is.
So it'd be like.
So it would be negative 3 over 2. If I move that over and divide it by 2, it would be negative 3 over 2. Then what's the slope on this one? Negative 3 over 2. The slope is the same. M is the same. Write that down. The answer is no solution. Why is it no solution? Because they're parallel. Okay? Solving by graphing is the hardest method. One mistake, and you get lines that look like this that intersect, and you say one solution and the answer is 4, 4, it's all wrong. Okay, you have to do all the graphing correct to be able to say no solution. Yes?
So like how the first and second one, the 3x plus 2y are both the same, but it equals different, wouldn't then you automatically know?
Yes. Yes. But it won't always be that easy. It won't always be that easy. Let's do one more. I think you need one more. Any questions? Let's do one more that has a solution. And I may let you do it on your own. Let's try one more. Let's see. x minus 2y is equal to 4, and 4x plus 2y is equal to 6. Now I wrote them separately like this just to show you they're not always stacked. Right? Sometimes they write one equation and then next to it they write the other equation. It makes no difference, especially when you're doing it by graph. Do you want me to do it or do you want to try it on your own?
You should try it.
All right, you try it on your own. I give you a real strong hint. You're going to get one solution. The trick is, can you get the right solution? Some people like to label it and say X-intercept and Y-intercept. If you want to be real organized, you can do that. Same thing over here, X-intercept and Y-intercept. This may help you. What is the X-intercept on this? And better yet, somebody tell me how we find the X-intercept. How do you find it? To find the X-intercept, what do? Cover up what? Y. It's that easy. To find the X-intercept, you simply cover up Y. So if I cover up Y, what is it telling me that X equals? 4. See how easy that is? The X-intercept equals 4. 1, 2, 3, 4. I put a dot. Boom, I'm halfway there. What is the Y-intercept on this problem? How do I find it? How do I find the Y-intercept? Cover up X. What is the Y-intercept? -2. So here's -2. 1, 2. I put my dot, and there's my line. Best you can. Doesn't have to be exact. Just do the best you can. All right, Owen, what's the X-intercept on the next one?
3/2.
3/2, exactly right. Which is what as a decimal? 1.5. So here's 1, here's 2. Pick 1.5 right in the middle, you're good to go. Don't freak out about fractions. 3/2, some people get all hung up on it. 3/2 is not so bad. Just do the best you can. What's the Y-intercept, Owen?
3.
3/2, which was 1.5. Say it again, 3.
Yeah.
The Y-intercept's 3, so 1, 2, 3. Here's one thing that people don't do, and it messes them up. See how all my slashes are equal distant in between each other? Your graph is going to be off if you do all of these, and then you got these that are like that. Right? They should all be equal distant between one another, as best you can. If you're bad at that, think about getting graph paper. Alright, so I got my 2. I graph my line. Now comes the hard part. Now I've got to figure out where I think these two intersect. What do I think? Where do I think they intersect? Happens to be the same point as the other problem, but that's okay. 2, -1 is my educated guess of where I think they intersect. Now what do I have to do? I got to plug it in and check it. 2 and -1 checks. 2 and -1 checks. Don't forget, write it down. Don't forget to check. Because you may have said 2, -2. And if you pick 2, -2 because your graph's a hand graph and it's off a little bit, you're going to miss the problem. You must check to make sure that you guessed correctly. Okay? Any questions? Anybody have any questions? All right. What are the 3 methods to solve systems of equations? Graphing, substitution, elimination. What are your 3 answers for systems of equations? One solution, no solution, infinitely many. Which do you get more than any other? One solution. Most of the time the answer is one solution. Okay, but there is a possibility that they'd be parallel. There is a possibility that they would overlap. Okay, questions? All right, good job on the tape. 15 minutes.